Hi everybody, I'm Carl Graffour. This year I've assisted the Arizona Department of Education with the design of Arizona's new computer science standards. Now we're creating these webinars to help teachers quickly get up to speed on the basics of computer science, those new computer science standards, and hopefully to help them integrate those standards into their own classrooms. This is our webinar series 2, Essential Concepts. There will be 5 sections in this series with 1 video per section. The section we're discussing today is computing systems. There will be 3 different webinar series in total. Series 1 discussed what is and isn't computer science. Webinar Series 2, this series, will cover the 5 essential concepts of the computer science standards. Webinar Series 3 will discuss the integration of computer science into other disciplines. Each series of webinars will have between 3 and 5 short video segments. So where are they? The approved computer science standards are available for download at the address on the screen. There's also a download link for the standards broken out by essential concepts on the same page instead of by grade. It'll help more easily show progression through the grade levels. Today's takeaway: the essential concept of computing system covers standards about computing devices, hardware and software, and troubleshooting. So what are the essential concepts? Well, they're categories that represent major content areas in the field of computer science. They represent specific areas of disciplinary importance rather than abstract general ideas. Each essential concept is supported by various sub-concepts that represent specific ideas within that concept. This figure provides a visual representation. Each essential concept is color-coded to differentiate it from the next. The color scheme is the same as shown on this slide. All grades are color-coded in the same way, meaning that in all grades, the essential concept of computing systems will be in the red color. Computing systems refers to and involves the interaction that people have with a wide variety of computing devices that collect, store, analyze, and act upon information in ways that can affect human capabilities both positively and negatively. The physical components, hardware, and instructions, software, that make up a computing system communicate and process information in a digital form. And troubleshooting, which is a systematic approach to problem solving. This slide shows a progression of the subconcept of hardware and software within the essential concept of computing systems. This particular progression is an example of grades 4, 6, and 8. You can see how this subconcept grows from 4th graders being able to discuss binary, which is using zeros and ones in communications, to 6th graders explaining how hardware and software gather disparate types of data from sensors, to 8th graders being able to design a mobile application that uses disparate sensors to gather data, stores that data, and finally displays that data. As you can see, the same standard becomes progressively more complex through higher grade levels. Lesson inclusion. Some ways that you could include lessons on binary and operating systems into your classrooms. For elementary school teachers, making bracelets or necklaces out of 2 colors of beads that represent a student's name, always a hit. Binary is a language made up of strictly zeros and ones. These are arranged in a pattern to represent natural language. In binary, an A is represented as 0, 1, 1, 0, 0, 0, 0, 1. Each letter, number, and character on your keyboard is represented by a series of 8 zeros and ones. This allows binary to be translated into any language and represent all language simultaneously. Having a student convert their name into binary using 2 different colored beads and putting those beads on either a bracelet or a necklace depending on how long the student's name is. Again, always a hit. The URLs next to the elementary section point to an elementary grade level lesson plan for binary and a lesson plan specifically about the binary bead activity. For middle schools, using Morse code and sending messages in class while not getting in trouble, that being the best part, of course. Teaches about encoding and decoding. The URL next to the middle school section points to a page of Morse code activities to include audio files that'll help give students an example of what Morse code is. While Morse code uses a dash and a dot, only two separate things, it's not truly a binary language. For high school, modeling how operating systems work, even down to the binary or machine code level, will truly gauge a student's understanding of the subject matter. So students could create a model of how computers use and convert binary into operating systems. They could map this out in Excel or even create an animation to show how it's actually doing so. So today's takeaway. What you should have taken away from today's video was an overview of the details of the essential concept of computing systems. Thank you for your time, and please watch out for our next video. Thanks.